This is the second video that we're looking at. This is from a assignment at the university I teach at. And so in another video we did problem 1, and that turned out to be exponential regression. So you're going to be getting a scatter plot and looking at the scatter plot and deciding what kind of regression do you have. So now we're on question 2. Okay, so let's start this one from scratch. It says the data here are from the Capital Bike Share system in Washington, D.C. in 2011-2012. The table shows the average number of bicycle rentals R per day as a function of average daily temperature T in degrees Fahrenheit. So your temperature is going to affect your business, definitely. And this time, so last time our table gave our values vertically in columns. So that first column was our X values and the second column was our Y values. But this table, our X and Y values are in rows. So the first row I'm going to take as my X values. The second row I'm going to take as my Y values. And then to get the scatter plot, we're going to want to see what these points are. So X comma Y. And we'd like to see them graphed. And we can see that nicely with graphing calculators. Back in the olden days, you had to graph them by hand. And if you look at the numbers there, that's just horrible. So we're going to put the X values in list 1, and we're going to put the Y values in list 2. Okay. So let me get out of here. I'll come to stat, and if I press enter, you can see I've got list values from a previous problem. So I'm going to need to clear those lists. So I'm going to click on stat, and I'm going to come down here to clear list, press enter, and then tell it I want it to clear list 1 and list 2. So second 1, comma, second 2, and then press enter. And so now if I click on stat and press enter, and I come over here to list 1, and I'm going to put my temperature values in there. So it's not too long a list. 53. It just takes me a bit longer because I'm using an emulator. If I had a physical calculator, I could do this a lot quicker. Okay, and then I am going to check. I'm going to go back up and I'm going to check. Always double check. Always, always. Okay, I'm good to go. Now let's go with list 2, 981. They still had 981 bike rentals when the temperature was 5.9 degrees Fahrenheit. My goodness. I mean, lots of times we just enter in the numbers blindly and we don't even give it a second thought. But where were these 981 people from? The North Pole? Okay. Almost there. 6290. Okay, now I do need to double check that because I was yakking. All right. Yes. Yes. Yep. All right. So I'm confident I have entered my list incorrect. It is so important to get your lists correct. You make one mistake in there and poof, everything's wrong. Okay. So now I want to get this scatter plot. I want to graph those points and I want to get it in the best window. And on this departmental assignment, you are expected to fill in these and to actually plot the points. So I'm going to get out of this window. I am going to go to second and then y equal, and then I'm just going to click enter. And where it's flashing, I do want my plots on, so I'm going to press enter. And everything else is the default for what I need. The default where it's shadowed there, highlighted, is scatterplot. And the default for your X values is list 1, and the default for your Y values is list 2. And then I'm going to have my marks shown with this default plot point there. So I'm just going to now press window. So I did press enter there. Okay. So if I just scroll down, you can see the plots now on. So I'm going to press window. I don't need to do anything else. I shouldn't need to do anything else. Oh, I want to get out of that. So let me press down, and then if I just click on window. Okay. So let me do that again. Second y equals, and the plots are on, and then I just scroll all the way down here, and then I click on window. Now, these values are from a previous problem, from problem 1. I'm going to get new values for this problem. Now, my X values go from 5.9 to 81.8. And I want my minimum and maximum to be nice. And I'm not going to take the literal minimum and maximum. So instead of 5.9 to 81.8, I'm going to take mine from, say, 0 to 100. Because then I'll be able to divide up these grid marks much easier. Okay, you're not going to be able to divide your grid marks up if you take the literal. Okay, so I'm just going to have my X min to be 0 and my X max to be 100. All right, now, what about the scale? I want grid marks here. I don't want my grid marks too close, and I don't want my grid marks too far apart. You know, I don't want that. So how much should a grid mark be between 0 and 100? I could make a grid mark for every 10 units. That would give me 10 grid marks here. That might be okay. So I'm going to put a 10 in there. Oops. Okay, so I'm going to try that. I might change it. So that's a 10. Then for my Y min and Y max, okay, I might take this from 900 to 7,000. Nice round numbers. I'm not going to take it from 981 to 6786. So let me enter those in. So I'm going to go from 900. So I'm just writing over the old numbers up to 7,000. Now, what should my grid marks be there? If I take it by hundreds, 9,000, 900, 1,000, then 1,100. No, they're going to be way too close together. So I might take this. Actually, I've changed my mind. I might go back to 0. Okay. Might go back to 0. Yep, 0 to 7,000. And then I'll make every grid mark be 1,000 units. So again, it's okay. That's what I'm going to go with. Now, if the scale doesn't look right, then I can change that. Okay. So let me try that, and I'm just going to press graph. Oh, I like that. See how I've got actual grid marks there that are evenly spread out? There's not too many of them. They're not too close, and they're not too far apart. So now the instructions say to show the tick marks. So for my X scale, if I go from 0 to 100, and every grid mark is 10 units. So the way I like to do it is the halfway mark would be there. So that would be at 50. And so 10, 20, 10, 20, 30, 40. Okay, so about 10, 20, 30, 40. Make that a little bit. So this is where it gets a little fiddly. 40, 50, 60, 70, 80, 90, 100. I think that looks pretty good for freehand. And then my vertical scale. So I start from 0 and go up to 7,000, and every grid mark is 1,000. So 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. Okay, I'm really happy with that. That is what the department wants. It wants you to show the grid marks, and the scale that I've written here is going to be good. Now I am going to sketch what we see here. Now, you're not going to just look at this and then do that willy-nilly. No, the whole reason that we have grid marks there and that the department wants you to do it like this is they want you now to sketch it, not looking at this, but let's look at the first point. It's 5.9 comma 981. Now this grid mark is 10, so 5.9 would be about there. And then 981, well, this grid mark's 1,000. So that's going to be about there. Okay. My next point would be 18 comma 2493. So 20's here, 18 would be about there. And then 2493 is very close to 2,500. And 1,000, 2,000, 2,500 would be about there. And see, let's look at this. See how just doing it this way, I am getting a very accurate reproduction of this. All right, 34.8, comma, 3624. So 30 is here, 40 here. 34.8 is about halfway. And then 3624. So 1,000, 2,000, 3,000, 3.5, 36 would be about there. And then the next one, 53.7 comma 4917. So 10, 20, 30, 40, 50. 53 would be about there. And then 4917 is very close to 5,000. So 1,000, 2, 3, 4, about there. Look at how good this is turning out. So I'm being deliberate here to be as accurate as possible. 61.3 comma 5740. So 60, 10, 20, 30, 40, 50, 61.3 be about there. And 5740 be just below 6,000. And 6,000's there and just below it. Okay, nearly there. This pairing 72.1, 10, 20, 30, 40, 50, 60, 72.1, about there, and 6290, so just above 6,000. And then finally, 81.8. So there's 80. 81.8 is about there. And 67.86, very close to that. Look at how good that is. That is really good for freehand. Okay. And so let me just take a little screenshot of that. Just have that. And I might want to save that. All right, I'm going to save that. Okay. So that's what the department is expecting you to do. Okay. Now, if we look at this, what kind of a relationship do we have here? And it very much looks to me like we have a linear relationship. That these points are coalescing around some line. All right. Now, I'm drawing this in red because you are not to draw the line in here. Okay, I'm just doing this because you need to make up your mind what kind of relation, what kind of regression formula we're going to use. Okay. So it very much looks like to me that we are going to have linear regression. Okay. So what do we do? What do we do? All right, now I'm going to get rid of these and let's go down, write the regression equation. So we have determined that it's linear regression. So I'm going to get my calculator to do this for me. I need to get out of here. I'm going to go to Stat. I'm going to go to Calc, and then I'm going to come down here to number 4, LinReg, linear regression. The default is our X list is list 1. Our Y list is list 2. Frequency list, leave that blank. Now, you have the option here to store your regression equation in its entirety. Okay, well, I can do that. You click on vars, then you scroll over to Y vars and press enter, and press enter again. And it has stored that complete equation in your first function definition when you click on y equals. And then I'm going to come down here and press on calculate. Okay, so here is what you are to do. Here is what you're not to do. And I have students do this. They copy it verbatim. And guess what the department says? I have to mark that. Department says that's a big fat 0. Okay, so I have guidelines where I have to mark stuff. Okay, this is not the regression equation. Okay, you don't just do that and then copy it there. No, no, no. So red is wrong. Okay, so I'm still, what this says is y equals, notice I'm still doing this in red, and it says to the 10,000ths place. Well, that means to 4 decimal places. So y is equal to a, which is 4 decimal places, is 75.1478 times x plus b. And b to 4 places is 887.5104. Now, this is the regression equation that your calculator gives to you. Your calculator gives you the regression equation in x and y. That's not how the department wants you to write it up, because at the very beginning of this lecture, yes, these are our x values that we put in list 1, and these are our y values that we put in list 2. But notice that these are using different letters. So what we need to do is we need to write our regression equation with the letters in the chart. So instead of Y, we're going to use capital R. Let me write it here. And I'm going to leave a bit of a space there because you're going to see what I'm going to do in a minute. Then 75.1478. And then instead of X, I'm going to write a capital T. And then plus 887.5104. Now, R is a function, and it's a function of T. So I'm going to write that. So this is not R times T. This is R evaluated at T. So now, this is what the department expects you to write for that answer. Okay, so that is the equation. That's my regression equation. All right, use the regression equation to estimate the number of bicycle rentals in Washington, D.C. on a day when the average temperature is 65 degrees. So that's your T value. So when T is 65 degrees, estimate the number of bicycle rentals. You want to find R of T. So there's two ways you can do this. I'll keep it on red. One is because you're not supposed to write this on the paper. This is what you write on scrap paper. Do not do calculations on your answer sheet. So what I'm writing is in red is what you do on your scrap paper. One way you can do this is just to do it directly using this formula that you got to 4 places. And so wherever there's a T, I'm going to replace that. So it's going to be 71.1478 times 65. So this is R evaluated at 65. And then it says to round your answer to the nearest whole number. Okay. And then I'm just going to do that directly. So 75.1478 times 65, and then plus 887.5104. Enter. Now, if I round that to the nearest whole number, it's approximately 5,772. Okay. Second way is we saved the regression equation in total. So let's use calculator to get R evaluated at 65, and it would actually be a more accurate answer because it saved it rounded to all of the, taken to all the decimal places it was given. So I'm going to click on bars. I'm going to go to Y bars. I'm going to press enter. And I'm going to press enter again. And then this Y1 comes up. Well, I want to evaluate that Y1 at 65. So Y1 is where they've stored R in your calculator. So I need to provide the 65 in parentheses. And then I'm going to press enter. Okay. And you see I get the same number, rounded. So either way, I get the same number. Now, if you watch my previous video on question 1, we actually got different numbers here. I think one was something 39 and the other one was something 40. Okay, and the department would accept both answers. Okay, but here, luckily, it doesn't matter which way you do it, you get the same thing. So 5772. Now, in black, I'm going to write what the department wants you to write here. So all of this red stuff should have been on scrap paper, okay? So when we come here, if you write this as your answer, my instructions from the department are to mark it wrong, because your instructions that you're given at the beginning is to give your answer as a full sentence. So the number of bicycle rentals in Washington, D.C. on a day when the average temperature is 65 degrees Fahrenheit is approximately 5,772. Okay, that is what the department wants you to write. So this is a departmental exam. Everybody at the entire university who takes this course has the same set. So all of us different lecturers, we have to mark it to a standard. We're given a sheet on how we have to mark it. So you're expected to write that out as a full sentence. Okay, so I hope that helped you answer your problem two. Now, just because my problem two was in this practice problem was a linear regression doesn't necessarily mean that your problem two will be a linear regression. So in this assignment, problem one was exponential, problem two was linear. That's just how it worked out in this particular example. So you will need to decide, do you have linear regression? Do you have exponential regression? Or do you have quadratic regression or cubic? Okay. Oh, and also if I go back and click on graph now that regression formula, the linear regression formula has been saved, it'll show up in my scatter plot. And that's pretty darn good, isn't it? That is the line of best fit. Okay. All right, so I am going to stop the video, and I hope this helped you.